All right. Welcome to Friday. We're going to do a little bit more work today on lesson 14.4, and we are going to focus on this second part, the derivative. We'll actually finish things up on Monday, so something to look forward to for class on Monday. So a definition to start with, if y is some function f of x, and c is a number in the domain of f, then the derivative at c is denoted by f with that little apostrophe c, and it's read f prime of c, and the definition for f prime for the derivative is it's the limit as x approaches c of f of x minus f of c divided by x minus c, provided the limit exists. So those things that we've been doing to this point all have led to this definition of what a derivative is. We're going to look at a couple of different ways to evaluate derivatives today. The first way is just going to be using that definition. So find the derivative of f of x equals 2x squared minus 5x at the value 2. That is, find the derivative of f at 2. So in order to use our definition, we need to first figure out what f of 2 is. And that looks like 2 squared, which is 4, times 2 is 8, minus 10, negative 2. So now we want to find the limit as x approaches 2 of f of x, 2x squared minus 5x minus f of c. So minus negative 2 would be plus 2 over x minus 2. And what we would really like to do is factor the numerator, because, and as we saw yesterday and even a little bit earlier, if I plugged in 2 for x, I would get 0 over 0, and we want to, that doesn't help us a whole lot. We want to eliminate that 0. So factoring, and more importantly, we want to factor, we want one of our factors to be x minus 2, and it should be. Okay? It might require either long division, which I know is everyone's favorite, or synthetic division, if you remember that. I'm going to just show quick long division. You could also use factoring. It is a quadratic, so it should factor as well. But that 2 in front sometimes drives students crazy. So what do I multiply x by to get 2x squared? Well, that would be 2x. So it would give me 2x squared minus 4x. And I would get minus x plus 2. What do I multiply x by to get minus x? Well, that would be minus 1. Subtract, and I get 0, which is what I want. So 2x squared minus 5x plus 2 factors into x minus 2, 2x minus 1. And we have common factor that cancels out. So for our limit, we can just ignore that factor. And if I plug 2 in, I get 4 minus 1, which is 3. All right. Most graphing calculators have a way to find a derivative. It's very nice. Actually, I'm going to show you two ways if you have a Texas Instruments calculator. So I'm going to find the derivative of 2x squared minus 5x at the value 2 using the graphing calculator. So one way is in the math menu. It's option 8 and derive. And what you do is you put the variable that you have your function in terms of, so d over dx, type in your function, and the value that you want to evaluate it at. So if you have a TI 84 or newer, that is the way you're going to do it. And then press enter. You get the same answer, 3. Now, if you have an 83 plus or an older Texas Instruments calculator, you won't get, it won't look like that. So I'm going to go here and go to classic. Maybe. There we go. So what it'll look like for you is it'll go like this. You'll go still not 9, 8. And what you'll need to do is type in the function, comma, the variable, which is x, comma, and the value we want to evaluate it at, which in this case was 2. Okay, so depending upon which calculator you have, you may need to do one or the other, which is great. So that's one way, just using the main screen. You could also plug your function into the y equals 2x squared minus 5x. And I'm going to go with my standard window. And if you go second trace, you'll see option 6, dy over dx. That means the derivative. So option 6, and then just type in the x value. We want it at x equals 2, and so the derivative at 2 is 3, and the point there is 2, -2, but we want the dy over dx value 3, which again matches with our other the value, the same value, the other ways that we've calculated the derivative. Okay. So one more thing we're going to look at just in general. What if I want to find the derivative of x squared at some value c, whatever c happens to be? So I'm going to take the limit. I'm going to do this one by the definition. I can't use my calculator because I don't know what c is. I take f of x minus f of c. So if I plug c in for x, I would get c squared over x minus c. If I factor the numerator, x squared minus c squared, that's a difference of squares. I get that common factor that cancels. So I'm left with the limit as x approaches c of x plus c. To calculate that limit, I plug c in. So I would get in for x. So I would get c plus c which is just 2c. So using the algebraic method, you can find kind of a general idea. So now if I wanted the derivative of x squared at 7, I would just plug 7 in for c. I have a general formula now for any derivative of x squared. Kind of helpful. So for your homework, you're going to be doing derivatives. Some will actually say use the calculator. And if you don't have a calculator at home, I will put a couple different ways that you can get a calculator, either download it or use your computer and get a simulator, graphing calculator simulator that way. So everyone should be able to access the graphing calculator. So your assignment, 21 to 29, the odds, 33 to 36, all. 33 through 36, I believe those are the ones that are going to ask you to use the graphing calculator to find the derivative. And you can use it again for any of the 3 ways that I showed with the graphing calculator. Have a wonderful weekend. Just a reminder that next week, class periods are a little bit different. So for 5th hour, we will be meeting at 11:15 until 12:25 next week.